Military weapons, tools of immense power and precision. Have you ever wondered how they are made, what materials are used, and why they cost so much? In this video, we'll dive into the world of military-grade weaponry, exploring the journey from raw materials to battlefield-ready tools of war. From the fiery heart of a grenade to the intricate circuitry of a guided missile, we'll uncover the secrets behind their creation. We will delve into the factories and testing grounds where these instruments of destruction are born, examining the delicate balance between engineering brilliance and the sobering reality of their purpose. Join me as we embark on a journey into the world of military weapons, exploring not just their mechanics but also their impact on our world and the ethical questions they raise. From the rudimentary weapons of ancient times to the sophisticated technology of today, we'll trace the evolution of military weaponry, highlighting key advancements that have shaped modern warfare. Understanding the historical context and technological progress helps us appreciate the complexity and innovation behind these powerful tools. Our exploration begins with a seemingly simple weapon, the grenade. Often no larger than a clenched fist, the grenade belies a complex dance of engineering and chemistry within its metallic shell. Most grenades are crafted from robust steel casings. Within these shells lies explosive potential, often TNT or Composition B. The fuse mechanism, typically forged from zinc or aluminum alloys, ensures precise detonation. Grenades come in various types, each designed for specific purposes. Fragmentation grenades are lethal, dispersing shrapnel upon explosion. Smoke grenades create a smoke screen for concealment, while stun grenades disorient targets with a blinding flash and loud bang. Moving to a larger scale, we encounter the missile, a weapon of greater complexity and force. A missile can be divided into four key components: the warhead, guidance system, propulsion system, and casing. Within this protective shell lies the warhead, the heart of the missile's power. Missiles also vary in type and function. Surface-to-air missiles target aircraft, air-to-surface missiles strike ground targets, and ballistic missiles deliver warheads over long distances. The guidance system, often a sophisticated array of sensors and electronics, ensures the missile reaches its intended target with precision. Propulsion systems, ranging from solid rocket fuel to advanced jet engines, provide the necessary thrust to propel the missile towards its target. In modern warfare, these weapons play crucial roles, from tactical strikes to strategic deterrence, shaping the battlefield with their formidable capabilities. The cost of military weapons extends far beyond the raw materials used in their construction. It's a price tag that reflects countless hours of research and development, meticulous engineering, and rigorous testing. Developing a new missile system, for example, can consume years, even decades, and cost billions of dollars. Take, for instance, the US Tomahawk missile program, a marvel of modern military technology. Its development reportedly consumed over £1.4 billion, a figure that underscores the immense financial commitment required to bring such sophisticated weapons to life. And that's just the beginning. Once developed, each individual Tomahawk missile carries a production cost of an additional £1 million. This staggering figure reflects the precision engineering, advanced materials, and sophisticated guidance systems packed into each missile. A significant portion of the expense stems from an unwavering commitment to reliability. These weapons, designed for the unforgiving crucible of war, must operate flawlessly under the most extreme conditions imaginable. Whether facing the scorching heat of a desert battlefield or the bone-chilling cold of the Arctic, their performance must be unwavering. This demand for absolute reliability necessitates rigorous testing and meticulous quality control, factors that inevitably contribute to the high price tag associated with military weapons. Breaking down the costs, we see that research and development can account for up to 30% of the total expenditure. Engineering and prototype testing add another 25%, while production and materials contribute around 20%. Comparatively, the automotive industry spends about 5% on R&D, highlighting the unique financial demands of military technology. The remaining costs are driven by rigorous testing, quality control, and the need for absolute reliability, which are non-negotiable in the defense sector. These factors collectively ensure that military weapons are not only effective but also capable of withstanding the harshest conditions, justifying their high costs. Military weapons forged in the fires of conflict demand materials that can withstand the most extreme conditions imaginable. Steel, with its remarkable strength and ability to fragment upon explosion, forms the backbone of many weapons, including the ubiquitous grenade. Its high tensile strength and durability make it ideal for withstanding the intense pressures and temperatures of an explosion. Missiles, on the other hand, require a different breed of materials. Carbon fiber composites and aluminum alloys, chosen for their exceptional strength-to-weight ratio, allow these weapons to soar effortlessly through the air while carrying a deadly payload. Carbon fiber composites provide high stiffness and low weight, while aluminum alloys offer excellent corrosion resistance and thermal conductivity. The explosive heart of these weapons, the materials that give them their devastating power, are concoctions of carefully calibrated chemistry, RDX, HMX, PTN. These are not names whispered in hushed tones in clandestine laboratories, but rather the cornerstones of modern explosives. RDX is known for its high detonation velocity and stability, HMX for its superior explosive power, and PTN for its high brisance and ease of detonation. Synthesized in specialized facilities, these compounds are chosen for their high energy density and remarkable stability. Their molecular structures are designed to release maximum energy upon detonation while maintaining safety during handling and storage. But the materials used in weapons manufacturing extend beyond the realm of metal and explosives. The digital age has ushered in a new era of warfare, one where microchips and processors are as vital as gunpowder and steel. Electronic components, like the microprocessors that guide missiles to their targets, are crafted from silicon and other rare earth elements. Silicon is prized for its semiconductor properties, while rare earth elements are essential for their magnetic and conductive characteristics. These tiny components, often overlooked, are the brains behind the brawn, enabling the precision and lethality that define modern warfare. Their intricate designs and robust performance ensure that modern weapons can operate with unparalleled accuracy and efficiency. Chapter 4. A race against time production timelines of weapons. The time it takes to produce a weapon is as varied as the weapons themselves. A simple grenade, a tool of readily available destruction, might be assembled in bulk in a matter of hours. Factories, humming with an almost clinical efficiency, churn out these instruments of war with a speed that belies their deadly purpose. However, the production of a sophisticated missile, a weapon like the Patriot, is a far more intricate and time-consuming process. Months of painstaking assembly and rigorous testing are required to ensure that every component, from the smallest microchip to the powerful engine, functions flawlessly. Warheads, especially those harboring the terrifying power of nuclear fission, represent the pinnacle of this complexity. Years can be consumed in their design and construction, a testament to the intricate physics and engineering involved. The most destructive weapons ever conceived, their creation is a paradox of meticulous care and terrifying potential. Strict safety protocols designed to prevent accidents and ensure the secure handling of these deadly materials add further layers of complexity to the process. Various stages of production, from initial design to final assembly, are meticulously planned. Delays can occur due to supply chain issues, technological challenges, or stringent testing requirements. Each stage must be completed with precision, as any error can lead to significant setbacks, impacting the overall timeline of weapon production. Chapter 5. Eyes in the sky, brains of steel, how weapons find their targets. In the theater of modern warfare, precision is paramount. Gone are the days of crude projectiles aimed in the general direction of the enemy. Today's weapons are guided by a symphony of technology, their trajectories dictated by complex algorithms and sophisticated sensors. Guidance systems, the brains of modern weapons, transform dumb projectiles into instruments of pinpoint accuracy. Missiles, once launched, are no longer at the mercy of gravity and wind, but are guided by an invisible hand to their targets. GPS guidance, perhaps the most familiar of these systems, relies on a constellation of satellites orbiting the Earth. These celestial beacons provide constant streams of data, allowing missiles to calculate their position and course with remarkable accuracy. Laser guidance, as its name suggests, employs a laser beam to illuminate the target. The missile, equipped with sensors that can detect the reflected laser light, adjusts its trajectory in real time, ensuring a direct hit. Radar guidance, another marvel of modern engineering, relies on onboard sensors to track and home in on the target. By emitting radio waves and analyzing their reflections, these systems can paint a detailed picture of the battlefield, identifying and locking onto enemy targets with unerring precision. Autonomous targeting systems take this a step further, using artificial intelligence to identify and engage targets without human intervention. The guidance system of a single Hellfire missile, for example, can cost upwards of £50,000, a testament to the value placed on precision in modern warfare. Chapter 6. The Evolution of Destruction, the Future of Weapon Manufacturing. The relentless march of technology knows no bounds, and the realm of military weapons is no exception. The battlefields of tomorrow will be shaped by automation, artificial intelligence, and a new generation of weapons that blur the line between science fiction and terrifying reality. Autonomous drones, unmanned aerial vehicles capable of independent thought and action, are already reshaping the landscape of warfare. These robotic warriors, guided by algorithms and artificial intelligence, can identify and engage targets with minimal human intervention. Hypersonic missiles, capable of blistering speeds exceeding Mach 5, represent another leap forward in destructive power. These weapons, propelled by cutting-edge scramjet technology, can evade even the most sophisticated defense systems, delivering their payloads with devastating speed and precision. Smart warheads, equipped with advanced sensors and onboard computers, are also on the horizon. These intelligent munitions can analyze their environment in real time, adjusting their trajectory or detonation point to maximize damage and minimize collateral casualties. This relentless pursuit of technological superiority comes at a cost, however. Hypersonic missiles, for example, can cost up to £3 million each, a testament to the cutting-edge engineering and materials required for their construction. The future of weapon manufacturing will also see the integration of new materials, designed to enhance durability, reduce weight, and improve overall performance. AI-driven manufacturing processes and robotic assembly lines will streamline production, ensuring precision and efficiency in creating the next generation of military hardware. Chapter 7. A Question of Ethics. The global impact of weapons manufacturing. The ingenuity and technological prowess displayed in the creation of military weapons is undeniable. Yet, we cannot ignore the ethical implications that cast a long shadow over this deadly craft. The immense cost of developing and producing these weapons often comes at the expense of social programs, diverting resources away from education, healthcare, and infrastructure. The use of these weapons, no matter how precise, inevitably results in loss of life and widespread destruction. Civilian populations, often caught in the crossfire, bear the brunt of these consequences. The proliferation of weapons, particularly those with indiscriminate destructive power, poses a constant threat to global security. As technology advances, the debate surrounding the role of military weapons in society will only intensify. The development of autonomous weapons systems, capable of making life or death decisions without human intervention, raises profound ethical questions about accountability and the future of warfare. The quest for ever more powerful weapons is a path fraught with danger. As we marvel at the ingenuity of their design, we must also grapple with the sobering reality of their purpose and the potential consequences of their use. Politically, the arms trade influences international relations, often leading to alliances and conflicts based on military capabilities. Economically, the defense industry generates significant revenue and employment, but it also diverts funds from other critical areas. Socially, the impact of weapons manufacturing is felt in communities worldwide, sparking movements for peace and the reallocation of resources to more humanitarian causes. From the simple grenade to the awe-inspiring power of a warhead, the creation of military weapons is a fascinating yet sobering process. We've delved into the intricate engineering, advanced materials, and the staggering costs involved in producing these instruments of destruction. Understanding these aspects gives us a glimpse into the complexities of modern warfare, but beyond the technical specifications lies a deeper question. What is the true cost of war? As we look to the future, the evolution of military weapons will undoubtedly continue. The balance between innovation and ethical considerations will shape the path ahead. Don't forget to like, share, and subscribe for more in-depth content. Before any military weapon is approved for use, it must undergo a series of rigorous testing procedures to ensure its reliability, durability, and effectiveness. These tests are crucial for maintaining the safety and operational readiness of military forces. First, we have stress tests. These are designed to push the weapon to its absolute limits, simulating extreme conditions such as high temperatures, freezing environments, and even underwater scenarios. The goal is to ensure that the weapon performs flawlessly, no matter the situation. Next, durability tests are conducted. These tests involve repeated use of the weapon over extended periods to check for wear and tear. For example, firearms undergo thousands of rounds of live fire to ensure they can handle prolonged use without malfunctioning. Grenades and missiles are subjected to impact tests to verify their robustness upon deployment. Accuracy tests are equally critical. Advanced targeting systems in modern weaponry must be precise. These tests involve firing the weapon at various ranges and angles to measure its accuracy and consistency. Any deviation can be catastrophic in real-world scenarios, so pinpoint precision is mandatory. In addition to these primary tests, weapons also undergo environmental testing, where they are exposed to salt water, sand, and other harsh elements to simulate battlefield conditions. Electromagnetic interference tests are also performed to ensure that electronic systems within the weapons are not disrupted by external signals. Only after successfully passing all these tests can a weapon be certified for deployment. This meticulous process ensures that when these weapons are used, they perform as expected, safeguarding the lives of those who rely on them. Understanding these testing procedures gives us a deeper appreciation for the complexity and precision involved in military weapon manufacturing. It also underscores the importance of continuous innovation and stringent quality control in developing tools that are as safe and effective as they are powerful. To truly appreciate the complexity and sophistication of modern military weapons, it's essential to understand their historical evolution. From rudimentary tools to advanced machinery, the journey of weapon development is a tale of human ingenuity and technological advancement. In ancient times, weapons were primarily made from stone and wood. The earliest known weapons, such as spears and clubs, were simple yet effective for hunting and combat. The invention of the bow and arrow marked a significant leap, allowing for ranged attacks and changing the dynamics of warfare. The discovery of metalworking around 3000 BCE revolutionized weaponry. Bronze and later iron were used to forge stronger and more durable weapons like swords, axes, and shields. These advancements were pivotal during the Bronze and Iron Ages, giving rise to powerful armies and empires. The Middle Ages saw the introduction of gunpowder from China to Europe, leading to the creation of firearms and cannons. This period marked the beginning of a new era in military technology, with firearms eventually replacing traditional melee weapons on the battlefield. The Industrial Revolution in the 18th and 19th centuries brought about mass production and mechanization, drastically changing weapon manufacturing. Innovations such as the rifled barrel, which improved accuracy, and the machine gun, which increased firing rates, defined modern warfare. The 20th century witnessed unprecedented advancements in military technology. World Wars I and II spurred the development of tanks, aircraft, and nuclear weapons. The Cold War era saw further innovations, including precision-guided missiles and advanced jet fighters. Today, military weapons are at the forefront of technological innovation. Modern advancements include drones, cyber warfare tools, and autonomous systems. These cutting-edge technologies continue to evolve, pushing the boundaries of what is possible in warfare. Understanding the historical evolution of military weapons highlights the relentless pursuit of innovation and the constant adaptation to new challenges. Each era's advancements have shaped the way wars are fought and have had profound impacts on global history and society. As we look to the future, it's clear that the evolution of military weapons will continue, driven by new technologies and the ever-present need for security and defense. This journey through history not only showcases human creativity, but also underscores the importance of ethical considerations in the development and use of these powerful tools. As we delve into the future of military weapons, it's crucial to address the ethical considerations and debates that surround their manufacturing and use. The development and deployment of these powerful tools have profound implications that extend far beyond the battlefield. One of the most pressing concerns is the impact on civilian populations. Modern warfare often blurs the line between combatants and non-combatants, leading to devastating consequences for innocent people. The use of advanced weaponry in urban areas can result in significant civilian casualties and widespread destruction, raising serious moral and ethical questions. International laws and treaties aim to mitigate these impacts by establishing rules of engagement and prohibiting certain types of weapons. The Geneva Conventions, for example, set standards for the humane treatment of individuals during conflict and restrict the use of weapons that cause unnecessary suffering. However, enforcing these laws remains a complex and challenging task. The debate over autonomous weapons, or killer robots, is another critical issue. These systems, capable of making life and death decisions without human intervention, raise concerns about accountability and the potential for unintended consequences. Critics argue that delegating such decisions to machines undermines human dignity and could lead to violations of international humanitarian law. Furthermore, the proliferation of military technology poses risks of escalation and arms races. Nations invest heavily in developing new weapons to maintain a strategic advantage. But this cycle of competition can lead to increased tensions and the potential for conflict. The ethical dilemma lies in balancing national security with the pursuit of global stability and peace. It's also essential to consider the environmental impact of military operations and weapons manufacturing. The production and testing of weapons can result in significant ecological damage, from deforestation and pollution to the long-term effects of unexploded ordnance. Addressing these environmental concerns is a critical aspect of the ethical debate surrounding military technology. As we continue to innovate and develop new military technologies, it's imperative to engage in ongoing discussions about their ethical implications. Policymakers, scientists, and the public must work together to ensure that the pursuit of security does not come at the expense of humanitarian values and global stability. In conclusion, the ethical considerations and debates surrounding military weapons are complex and multifaceted. While technological advancements offer new capabilities and advantages, they also present significant moral challenges. By addressing these issues thoughtfully and collaboratively, we can strive to create a future where the use of military technology aligns with our shared values and aspirations for a more peaceful world. Beyond the ethical considerations, the defense industry plays a significant role in shaping national and global economies. The economic impact of this sector extends far beyond the immediate production and deployment of military weapons. One of the most notable contributions of the defense industry is job creation. From engineers and scientists to factory workers and logistics specialists, the development and manufacturing of military technology provide employment opportunities for millions of people worldwide. These jobs often require specialized skills and training, leading to a highly skilled workforce that can contribute to other industries as well. Government spending on defense also has a profound economic impact. In many countries, defense budgets are among the largest components of national expenditure. This spending supports not only military operations, but also research and development, infrastructure, and procurement of advanced technologies. While some argue that these funds could be better allocated to social programs or other public services, the defense sector remains a critical driver of economic activity. Private contractors play a pivotal role in the defense industry. Companies that design, manufacture, and maintain military equipment often rely on government contracts for a significant portion of their revenue. These contracts can be highly lucrative, driving innovation and competition within the private sector. However, the reliance on private contractors also raises questions about transparency, accountability, and the influence of corporate interests on defense policy. The defense industry also has a ripple effect on related sectors. Advances in military technology often lead to innovations in civilian applications, such as telecommunications, transportation, and medical devices. This technology transfer can spur economic growth and improve quality of life, demonstrating the broader impact of defense-related research and development. On a global scale, the defense industry influences international trade and economic relations. Countries that export military equipment can strengthen their economic ties with allies and partners, while also enhancing their strategic influence. However, the global arms trade can also contribute to regional instability and conflict, highlighting the complex interplay between economic interests and geopolitical dynamics. In conclusion, the defense industry has a multifaceted economic impact that extends beyond the battlefield. It drives job creation, government spending, and technological innovation, while also shaping international trade and economic relations. As we navigate the challenges and opportunities of the defense sector, it's essential to consider both its economic benefits and its broader implications for global stability and security. As we look towards the future, technological innovations are rapidly transforming the landscape of modern warfare. One of the most groundbreaking advancements is the development of AI-guided missiles. These sophisticated weapons utilize artificial intelligence to identify and track targets with unprecedented accuracy. By learning from real-time data, AI-guided missiles can adapt to changing conditions, making them more effective and reducing the risk of collateral damage. Another significant innovation is the rise of drone warfare. Unmanned aerial vehicles, UAVs, have revolutionized military operations by providing real-time surveillance, reconnaissance, and strike capabilities. Drones offer the advantage of remote operation, reducing the risk to human pilots and allowing for more precise targeting. As drone technology continues to evolve, we can expect to see even more advanced models with enhanced autonomy and longer operational ranges. Cyber weapons represent a new frontier in modern warfare. These digital tools are designed to disrupt, degrade, or destroy enemy information systems. Cyber attacks can target critical infrastructure such as power grids and communication networks, causing widespread chaos and disruption. As nations increasingly rely on digital systems, the importance of cybersecurity in defense strategies cannot be overstated. Looking ahead, the future of weapon manufacturing is likely to be shaped by several emerging technologies. Quantum computing, for example, has the potential to revolutionize encryption and decryption processes, making communications more secure and intelligence gathering more efficient. Additionally, advancements in material science could lead to the development of lighter, stronger, and more resilient weaponry. The integration of augmented reality, AR, and virtual reality, VR, in training and operational planning is another exciting development. These technologies can create immersive simulations that enhance situational awareness and decision-making skills for military personnel. By providing realistic training environments, Arkansas and VR can help prepare soldiers for the complexities of modern combat. In conclusion, technological innovations are driving the evolution of modern weaponry, introducing new capabilities and challenges. As AI-guided missiles, drone warfare, and cyber weapons become more prevalent, the future of warfare will be defined by the interplay of cutting-edge technology and strategic ingenuity. It's crucial for policymakers, military leaders, and technologists to collaborate in navigating this rapidly changing landscape, ensuring that advancements in weaponry contribute to global security and stability. Like, share, subscribe. Thanks for watching.